environment is the earth. The earth is finite. Its capacity to provide space, to produce food, and to supply energy are all restricted. We depend upon these limited resources for survival, and yet we are increasing our population as if they were kingdom. This dilemma is at the root of our most critical environmental problems. On this map, population growth will be recorded from the year 1 AD to the present, and then projected to the year 2020. Population totals and locations are indicated by dots, each of which represents 1 million people. Historic reference points are provided by the images on the right. Its present growth rate continues. Our population will double in less than 40 years.
Hope that's. Can you turn this down? Well, I think you got the message. That I was actually going to show you. This is the end of the course. I'm going to show you the beginning of the course, a little video, but it was not in the right format. And it shows our favorite dung beetles copulating. And it's very graphic. And it looks just like humans, with the same rhythm, everything, same motions. So, the message of the course was, this is what this course has been about. Start with insects doing their thing, and you end up with humans doing their thing. And in between, nothing really has changed. The desire to engage in sex has not changed. The quest for status to determine sex, I mean, we've had this over and over again in the course, and I hope you realize by now that we've discussed so much from the Princeton project and other projects, how much social acceptance is an important part of fertility, that people determine their own fertility a lot because of what is the acceptable norm in the community. And aside from the direct status of having a lot of sons and a big family gives you big status because of protection and political power from the large family and economic security. But it's all tied in with status. And I think I mentioned too that, for instance, in Bangladesh, they looked at fertility as a function of religiosity, and one factor that had some effect was the religiosity of the particular family, but the much bigger effect was the religiosity of the community. It's all community acceptance, it's all status, and that comes directly from the chimpanzees. And of course, you're aware that a vast percentage of human consumption, and more, and the richer you get, the more of it is status consumption. I mean, the difference between a Mercedes and a Ford is basically status, that kind of thing. And you've also seen that between groups, the hostility between groups has basically not changed since chimpanzees. The maltreatment of females, the battering of females among chimpanzees, the battering of females among humans. It's all stayed about the same. So if I could have shown you that video, you'd have gotten the message that, and also why this is a biology course, or at least part of the reason, is because the fundaments of almost everything that we've talked about are the same set of behavioral propensities that are apparently wired into us in some way since our chimpanzee days. Okay, so this video that you did see, the main point is that the situation we are in now with respect to population is totally unprecedented in the history of humanity. There's just never been anything like it. And you also know something about the future. Come on. Here it'll come. Oh. Oh, it might help. No, I have to put it. I just put it. Here we go. Here we go.
Professor Lennon, what year was that video made?
What?
What year was that video made?
That video was made in, I wrote that down, I think 1990. And the projections, the actual numbers are pretty good for their projection uphill. This is not a new video, and I'll show you the situation. Okay, good. Why is this still there? Go away. Hang on, we're having. Now it should work. Okay, so these are the projections that the UN has put up for the future of population. So I think I showed you early in the course when I was discussing quantitative methods, the US Census Bureau projection, and that more or less mimics this one. But the UN shows you that there's a range. They do not know what's going to happen. And so they give you a range of possibilities for the future, and they do not call them predictions at all. They are simply projections, meaning that if X, Y, Z, P, or Q happens, then this will be the course of population. But they don't say which of these things is going to happen, if any of them. So what would you consider in terms of, say, fertility? What would you consider the most conservative projection? We know what's happened in the past. We know what the status is today. How should we make our future projection? Fertility staying the same, fertility going up, fertility going down? Thinks down, okay. So the UN, that's one of the projections. To my mind, the most conservative projection is that whatever we're at today, that's where we continue to be at. It's in the sense, that's what I think conservative means, that you preserve what's been in the past. Well, that's this projection, that the fertility that the world is at today continues just as it is. And the projection is carried out to 2050, and assuming that we are where we are, population will be 12 billion. We're now about 6.7 billion. Population will be not quite double what we are now, and rising ever faster. So that's the status quo assumption. The other assumptions are optimistic, that that fertility will come down, and they're not unreasonable assumptions, and the reason why some of you chose fertility coming down, because fertility has been coming down. So it's not a crazy presumption. But how much is it going to come down? So the UN gives you three possibilities. So this projection, which they call the high projection, assumes that fertility will come down another half of a child. Right now, this was based on the average fertility between 2000 and 2005, which was about 2.8 children, 2.85 children. And they're presuming in this projection that it'll come down another half a child the average for everyone on Earth, to 2.35, still above replacement level fertility. With that degree of optimism, that comes down another half a child, population keeps increasing, not as fast as this, and by 2050 we get to roughly 11 billion, and it's pretty much going up in a straight line. Now you can get a little bit more optimistic and say, well, it's going to come down a whole child's worth. And that's this scenario here. Now we're at 1.85. The whole world has come down to a quarter. The replacement level of fertility, as you know, is 2.1 children. So 1.85 is a quarter child below replacement fertility. And you can decide for yourself how much optimism is involved in assuming that's going to happen. But if that's the case, then population is like 9 billion in 2050 and continuing up, but clearly beginning to level off at that time. Now they get really optimistic, and they do this line, and that's it drops a child in half in this short amount of time, and that goes down to 1.35 children per woman, way below replacement fertility, and that's for the whole world. The assumptions are there. What is going on? Sorry about this. I don't know what's problematic here today. Yeah. So these are the UN's own statement of its assumptions. The constant fertility one, fertility remains constant at that average of more or less 2.8, 2.85. the high fertility assumption, they're calling a reduction from now the high fertility, 2.35 children, medium, 1.85, 1.35. And then they have a really miraculous assumption, the instant replacement assumption, which they don't bother to graph, which is each country immediately, like tomorrow, comes down to just the birth rate that will replace its population, no more, no less. So what should we notice about these things? Obviously, they're pretty arbitrary assumptions. No one knows what's going to happen in the future. No one claims to know what's going to happen in the future. And it's a sign that we just don't know enough about this issue. I mean, I've told you a lot of the basic stuff that's known, but we do not know enough to really predict. We asked at the beginning of the course, the middle, and the end of the course, why has fertility been coming down? What are the determinants of fertility? And you've gotten a whole lot of answers. If we knew the answer for sure, we would be able to predict, but the future is not terribly predictable. Okay, so these are projections, not predictions. They've got a huge range there from about 8 billion to about 12 billion. That's an uncertainty in the not terribly distant future of 50%. That's a very, very large degree of uncertainty. Only the most optimistic assumption, this last one, only the most optimistic projection has population decreasing by 2050. All the other assumptions show it continuing to increase right through 2050 with no statement about what might or might not happen beyond that. So in the medium variant, this is the one that they call the medium variant, and because they use that word medium, the press sort of takes this as well, the most likely or something. The UN does not say anything about the likelihood of any of these estimates, but hey, take your choice. In this rise that we're now increasing at like 2000 up to 2007, the average rise was about 78 million a year. In this scenario, by 2050, its population is still increasing by 30 million a year. So that's their medium variant. As far out as they're willing to even project, not predict, but even to project, population is still increasing by 30 million a year. I keep saying these are optimistic. Remember, none of these assume that fertility starts rising again. We have indeed had a fall in fertility, and there are certainly reasons to believe that if the world, we've had a fall in fertility, and we've also had really rather great progress in the world, say, since the end of World War II. I mean, people are staying alive, they're getting more educated. All parts of the world, China, India, Indonesia, are just unbelievably richer than they used to be, although still very poor, and pockets of real poverty exist. I mean, most of the world has just improved tremendously, both in the rich countries, the West, Japan, and in the poor countries. If you had to choose a date that you would like to be alive, but you couldn't choose who you would be or where you would be, the only reasonable date to choose is now. because the average human being on Earth was worse, going back as far as you want. Now, if you could choose to be a rich person, that's maybe another story. But if you just would be randomly seated anywhere, you choose to be now. So things have been getting better. There's no question about it. If things continue to get better, it's very reasonable to presume that one of these, maybe not this curve, but one of these more optimistic curves might take place. But there are a lot of reasons why things may not continue to get better. And in the paper segments of a paper that I wrote, I list a number of them. One of that I listed was economic collapse. And I was talking about the fairly small economic collapse in Asia in 1997, which had just happened at about that time. And I did not envision, as did no one, we have really now a global kind of a mega crash. And will we recover or not? Who knows? But if economic progress is one of the things that's required, or economic increase is one of the things that's required for population to keep coming down, then the global economy, who knows what's going to happen? It may very well turn around. Religious fundamentalism is another thing, that we know that it's not a particular religion, Christianity or Islam or Judaism, that matters, but it is the religiosity, the degree to which people are religious in whatever their religious tradition is. That latter makes a difference. And religious fundamentalism is basically increasing all across the world, including the United States. Of course, I read an article that Notre Dame is one of the great Catholic universities in America, and the priests, a number of the priests of the order that founded Notre Dame and still run it, President Obama was invited to be the speaker at graduation this year. And the priests didn't want him to be because he's pro-abortion. So the conservatism at one end of the spectrum of all religions is there and increasing. You see the Taliban, which are at one end of the Islamic spectrum. They are powerful now, increasingly powerful, not only in Afghanistan but now in Pakistan. And I don't know if you've been reading the newspapers, but they have now taken a provincial big city or capital. It was only like 30 miles or something from Islamabad, the capital of Pakistan. So they're increasing. The population of Orthodox Jews in Israel, because they reproduce so much faster than everyone else, is very close to overtaking the population of more moderate Jews. And the Palestinians and the Orthodox Jews in Israel are having a battle to see who can increase their fertility fast enough to sort of out reproduce the other, and et cetera. Another factor is the decline in support for international family planning programs. As you're undoubtedly aware, the population explosion, which was a very hot issue for the press and for all kinds of activist organizations in the 1960s and 1970s, has just fallen off the map. Our own School of Environmental Studies here at Forest Street does not have a single person that pays any attention to human population. Courses like this are taught basically nowhere else, very few places elsewhere. Environmental organizations won't go near the population issue. And so governments, not under any pressure from the citizens, are reducing their support of family planning. And this has already happened in large degree, as well as a lot of other good programs. And with the economic problems of all governments now, it's going to be even further. And yeah?
But don't economic problems exacerbate social problems that would incentivize governments to want to control their fertility?
Is that very good to say? So do economic problems exacerbate social problems so that people will want to more control their fertility?
Or the government has a much more vested interest in controlling fertility?
So what you say is reasonable, but the opposite of everything that we've sort of said in the course. That it's when things are getting better, that when people come from being, except for land availability, that when infant mortality goes down, people reduce their birth rate. When education is available, people reduce their birth rate. When countries get richer, people reduce their birth rate. So no, it's exactly the opposite and that you should definitely take that away from this course, that good things happen when things are already getting better. And the reduction in fertility goes along with, I didn't say cause, but goes along with an improvement in every kind of condition that you can count. And when the economy goes, I mean, in the 1997 Asian crisis, a lot of women working in the cities and not having at factories and sewing and so forth, not having children. They lost their jobs, they went back to the villages, and guess what they did? They started having children. So it's improvement in a situation that gets fertility down.
Sort of to go along with that question, maybe because it's more of a short-term economic decline, it's more of a shock and more of a depression that might cause people to temporarily reduce.
Okay, excellent. So what her question was, because this is a short term, more of an economic shock than a depression, maybe people will temporarily reduce their fertility. And that's a wonderful observation. And economists really don't know how to answer that. So when I started teaching this course, I co-taught it with a professor of economics. And he was teaching sort of the economic determinism. This is really what he believed. And he thought that as countries come up economically, fertility will come down more or less automatically. And he was of the mind that development is the best contraceptive. I've shown you, since then the data has shown, I think clearly shown that's not the case, but that was his belief then. Then comes this 1997 economic collapse in Asia. And I go up to this professor who I was not teaching with anymore, and I say to him, "Hi, gee, here's this economic collapse in Asia. What do you think will happen?" And he said to me, "I think fertility will go down," which is what you're saying, because conditions are getting worse, and what you're saying. And I was shocked, and I said, "But," and I won't say his name, "but that's exactly the opposite of what you taught in the course." And what he said to me was, "I think the theory is flexible enough to accommodate both results." Which means the theory didn't predict anything. If you can predict this and then the opposite, it doesn't predict anything. So we don't know the answer to this. I mean, first of all, we don't know if this is a temporary economic collapse. I mean, we hope it is, but no guarantees. And the data to figure out the difference between what's short term, which is undefined, and what's long term, which is undefined, very difficult to do. You may be right, you may be wrong. I think we just can't be certain about that. So, of course, the other factor which could cause things to go to hell in a handbasket is environmental collapse. That if the environment gets bad, if things start getting used up, if people really start starving or losing, not having water or whatever the environment will do first, and we'll talk maybe a little bit about what might happen first, then again, things could go backwards very, very fast. So, none of this are predictions that I'm saying. I'm just saying that here's all this optimism, all of these, except the constant one, all of those are optimistic presumptions. That may take place, but there's just as many reasons to think that no, things will turn around and fertility will go back up. And we just don't know the future. But what we can say that by any kind of reasonable assumption, for the next 40 years at least, we're in for a very significant increase in population. That is going to happen. So how does one concept, I'm trying to make this lecture at least somewhat about the environment, how does one relate this population increase to environmental destruction, to decay of the environment? This is not an easy question. There's so many variables between human population and environmental destruction that it's hard to pick out, what's just due to the population. And the simplest statement that you can make is that the total human environmental footprint is an idea come up by, I guess, some I don't know, is there a name attached to who came up with the use of the word footprint? Anyway, the idea of the total environmental impact of an individual, a city, a country, an industry, whatever, the environmental footprint is what's said. And in the simplest way of thinking about it, the environmental footprint is proportional to the number of people. Each people on Earth have an average footprint. The more people, the bigger the footprint. And that holds at any level, any assumptions you want to put on it. More people, bigger footprint. So that's fairly obvious. But it's doesn't tell you an awful lot. And so many years ago, a guy named John Holdren proposed sort of an expansion of that idea. And he is now Obama's, the director of the Office of Science and Technology, just recently appointed by President Obama. So at least you now have someone in power who thinks about population. And what he came up with was this equation. The environmental impact, he breaks it down. He says you don't have to worry only about population, but how rich is that population? There's a difference between rich people and poor people. What about the technology involved? So affluence is that we clearly know that rich people consume a lot more than poor people. Between the poorest groups on Earth and the richest, there's a factor of something like 40. Depending on how poor you want to go and how rich you want to go, that number can be almost anything, but 40 is a reasonable number to keep in mind. So affluence is certainly important, the amount of money your population has. And technology. So nowadays, if we want to knock down a forest, we use bulldozers and chainsaws, chainsaws that'll cut down a 40-foot tree with one swipe. And clearly, that technology allows you to have a much greater impact than if you're going out there with a little hand hatchet or maybe even a stone axe to try to chop down your tree. So the amount of technology that one has clearly makes a tremendous difference in how much destruction you can do. What you should notice is that so this is symbolized by IPAT. The impact is population, affluence, technology, all multiplied together. You should keep in mind that this is a tautology. Tautology means something which is always true. The equation is always true, and you can just see that from you define population just people. Affluence is the income per person, the number of dollars that person has. And technology is defined in this nice way of the impact per dollar spent, right? So that's how you're defining these terms, how you're measuring these terms. And you'll just notice that if you cross multiply, the persons and persons cancel out, the dollars and dollars cancel out. So your equation ends up that the impact is equal to the impact. So that's a sign of a true equation. True equation, it's a tautology is always the case. And I should show you that, for instance, this is a standard thing out of Science magazine, one of their stories about population. And what are they doing impact? Here's the first thing, that last impact per dollar. So that in this case, the impacts they're interested in is carbon budget. So they're talking about the carbon budget. They even use the word budget for that. And it's for each US dollar, this is a global figure they're going to give you, but they're calculating it in US dollars. For each dollar spent on something in the world, how much carbon is used. And so that's kilograms of carbon per dollar. And it's about a quarter. And it's changed somewhat over time, but not enormously. So it's gotten better. This is the lower the number, the better. That for each dollar of stuff that you buy, there's basically less carbon used to make it. So this kind of way of thinking about environmental impacts is now actually rather standard, and you really can't avoid this kind of thinking. One of the real important things about this that people make mistakes on all the time is that the factors multiply. That you don't add the population plus the affluence plus the technology, you multiply them. And one of there's a very important book, so I think it's called Something New Under the Sun, and the guy who wrote it, Yale tried to hire him as our environmental historian, and he was adding these factors and making all kinds of totally wrong conclusions, saying that, well, the rate of growth of affluence is so much, and the rate of growth of population is so much, so this one is more important than that one. Just saying utter nonsense because he didn't realize the importance of the fact that anything per capita is multiplied by the total population to get your global impact. And the global impact is something you're interested in, the total impact, the total amount of carbon dioxide. Not interested so much how much carbon dioxide I put into the air, but how much the 6-7 billion of us put into the air. Okay, now the equation looks simple and it's always true, and yet it's not as straightforward as one would like, because people take something beyond the tautological fact of it being true. What this, as I've described it, what this makes you think is, well, an increase in population is always bad. It always increases the impact. An increase in affluence is always bad. It always increases the impact. An improvement in technology is always bad. It increases the impact. That's not true. That as people get richer, as affluence goes up, they tend to spend a somewhat larger fraction of their income on environmental issues. that once you have a nice house and a nice car, a nice school, nice clothing, you may actually want to breathe nice air and look at something green and have a park to go walk into. So rich people do indeed spend more than poor people on environmental issues. So affluence can work both ways, and that's very important to remember. However, you have to step back a little bit and say, well, in the world, what fraction of our increasing affluence have we actually spent on the environment? And the increase, we've spent a very small fraction of it. So in fact, the overwhelming dominant effect of our affluence has indeed been to have a greater impact on the environment. And we've ameliorated that a little bit. I mean, very noticeable. The rivers in America, rich place. Rivers are really, a lot of rivers have been cleaned up. A lot of smog has been cleaned up. So we have made progress in certain very visible ways. We've exported a fair amount of our environmental concerns to other parts of the world by having them manufacture stuff and bringing it in here and knocking down their forests to bring in wood and so forth. And the Chinese and the Japanese have done just the same kind of thing. Similarly with technology, it doesn't always work one way. That yes, technology allows you to blow off a mountaintop to get some coal. You know, you've seen these horrific pictures of West Virginia and so forth, where a more or less beautiful mountain that's covered in trees and wood, just gone, and all that mountaintop becomes slag and pollutes rivers and acidifies rivers and does horrible things, and you have this ugly, scarred up land. So technology does that, but also improvement of technology, for instance, with the mining of copper. So when you replace copper wires with fiber optics, they're made of glass. And glass is made from sand. And the harvesting of sand doesn't do an awful lot of environmental destruction. So that's an improvement in the environment. And there's a number of examples of that. And again, you have to ask, cars, our current push now to make cars that use less gas, so that the good that it does use, it gets you to drive a mile, you use less gas. Not enormously less, but somewhat less. So technology can help you. And again, the standard question is, has our improvement in technology over the last 20, 30, 40, 50 years, whatever time window you want to deal with, has this allowed us to do more environmental destruction of the earth, or have we used a big enough fraction of it to improve the environment, our efficiency of use of the environment, that the things have gotten net better? And the answer is there's no question about what's happened. Because you see in this, again, this is more CO2 stuff, that here is the sources of CO2 addition into the air, which is a very good index of what's happening in the total economy. And what you see is the land use. So land adds into the CO2 by deforestation and using wood for timber and everything. So the land use, the changes in land use has not enormously changed. The width of that line is more or less the same over time. So the change in land use is putting about the same amount of carbon into the air as before. There's a little bit of other emissions, which we don't have to worry about, but fossil fuel combustion has just gone up, 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 up. So whatever the balance of our affluence and our technology, whatever the balance, well, we can see that is the balance of our use between using it to ameliorate the environment versus messing up the environment. Okay, we'll come back to this slide if we have a chance. In terms of the efficiency, that first factor, well, not the first factor, the dollars per carbon use, that is here, actually. The carbon use per dollar is quite interesting. That it has been coming down. From 1970, it was about a third of a kilogram of carbon per dollar, and that's come down to now something like a quarter of a kilogram per dollar spent. And that's just carbon, so you multiply that by almost 4 if you want to measure in CO2. because carbon is about 1/4 of each CO2 molecule. So it's basically, we now, for each dollar spent, we put out 2 pounds, a kilogram of carbon. So every time you go and buy something, just you give them $1 and say, that's 2 pounds of carbon I'm putting into, of carbon dioxide I'm putting into the atmosphere. It's a not crazy way of thinking about things. So what is worrying people now is that this has been a pretty good decline, but actually this is now turning out to be more significant than people thought. The rate of decline here, that's decline in efficiency of use of carbon, was about 1.3% a year. It's no longer declining, and this seems to have continued. It's now going up by 3.3%, 0.3% a year. So it looks like that we've picked the easy apples, the low-hanging fruit, as they say, in improving our carbon efficiency, and now we may be getting worse again. Okay, so all of that is about how to think about one of the ways of putting in a quantitative view of the relationship between population and the environmental impact. So there's many other considerations of the relationship between population and impact. One is the expansion of humans into almost every habitat on Earth. There's almost no limit to this. So I'll show you some extreme cases of this. Now what's going on? It's something that Malthus talked about. Remember we described what Malthus said. He was living in England just about 1800, and the population was increasing. And what did they do? So there was farmland. The best farmland was already farmed, but as there were more farmers, the farmers had to move on to more marginal land, less good land. And what he was thinking was that there's a law of diminishing returns, that you have farmers on good land, they're producing so much per farmer, and it's fairly good. England was not a very poor place. As population increases, they have to move on to drier land, swampier land, hillier land, and the production per farmer for these new farmers is less than those that had the best land. So while the total production grows, and remember Malthus showed a linear rise in total production, that with new people, total production grows, but population is growing like this. Since each new person produces less than an old person, he has to farm on worse land than the earlier farmers, the average productivity goes down. And that is a thing that has happened all through history. That of course humans, when they have a choice of land, when they're not crowded, when nobody else is standing around, they choose the best land, the easiest to get along with, to survive in. But then what happens is people move out into less good land. The pictures I'm going to show you are from Niger, which is in Sahel, just south of the Sahara Desert. It actually sticks up into the Sahara Desert. And this is a province of Niger called Azawak. And it's a huge province because there's not many people there. It's a big thing right on the edge of the Sahara. The population is 50,000 people. And in the dry season, they have 2 wells in the whole, for that whole huge territory, for all those 50,000 people, there are only 2 wells, and only one of them works regularly. During the rainy season, this is what it looks like in that country. They have, you can see, there's no water, nothing can grow in the ground. And some of the trees that can survive, grass doesn't survive this, it's too small, and when it loses water, it's gone. Trees can store water, basically, and survive fairly long periods of drought. So you get some, what's called scrub, in a sense, scrub forest. In the wet season, they're very joyous, they have lots of water. They think lots of water, but this is the amount of water that they have, and the people use it for all their functions. The animals, I know you can see an animal back here, the animals use it to drink and relieve themselves, and here's girls washing in this water. And this is in the good time of the year. This is the water that they have to survive on. The dry season is 9 months long. You have some rain, not a lot, but some rain for 3 months. Then the dry season is 9 months long. And then this is the labor value of children. These young girls must travel 35 miles to one of the 2 wells that are available. That's the average, depending on where they live. They have to walk, no mechanized transport. They walk 35 miles, and they can carry back only enough water so their families can drink 1 glass a day. Remember, we used to be told, it's now shown to be not really scientific, drink 8 glasses of water every day. They're living on one eighth of that amount of water. So you have to ask yourselves, why do people live in such a godforsaken place? You know, this life is so hard and so miserable, and what is the answer? The better places have somebody in them already. So the story, if you can do the sort of anthropological history, is virtually always that this tribe at one point lived in some much nicer place. But some tribe got more populous, got stronger in one way or another, was more vicious, and they got pushed out of what was their original aboriginal, fairly decent land onto more marginal land. And so while they may have been living there now for hundreds of years, in a sense it's not their own choice to live on such a miserable part of the world. When you read, and I think in the War Before Civilization, I gave you some readings from this book which calculated all the violence, it describes some peoples that have been pushed out into these marginal lands by stronger peoples. It gives you a number of examples of that. And of course, the big example, big modern example, is in America, that the European settlers pushed the American Indians, the Native Americans, into horrible lands. The stories of pushing the Cherokees from nice farmland and nice productive land in, say, North Carolina, and putting them to Oklahoma, which is half dry, or the Apaches, various Indians pushed them off into the desert. So you go see how miserably a lot of the American Indians now live in the Navajo reservations and so forth, and say, you know, my God, why do they want to live there? And they didn't want to live there. They weren't given a choice. They were pushed out. So, we're talking about dryness, which is one of the things that people just absolutely can't exist without water. So this is really the border of existence. But where it's very wet, you remember you read in Bangladesh that people living on the mudflats. And the monsoon season comes in, the water rises or a flood comes, and they're just washed out. Those people didn't choose to live there. There's no land anywhere else, so they do whatever they can. The Eskimos that live up on the polar ice cap, there are some Eskimos that are apparently constantly on the ice cap and don't have a base on land. So when we think of people living in these very marginal circumstances, one attributes, I mean, there's famines. The people live in this region have famines every so often. There's great drought, as you know right now. Parts of Africa have terrible drought. California has a terrible drought. The Colorado River Basin is having drought. So when this happens, it's always when then the people get into great trouble and they can easily starve to death, and some advanced countries may or may not send them food, and sending them food has its own problems. But it's always attributed to environmental variability, to climatic troubles. And no one ever asked the question, why have these people been pushed into this incredibly inhospitable region? I mean, part of the ecology of that region is you're going to have droughts every so often, and sometimes they're going to last for years and be very severe. And the drought in California has now lasted for years. So everything in the environment, the relationship between the population and environment is circular. That people affect the environment, then the environment comes and bites them back. It comes back to them. And water is one of the key things, and probably what will give out first. When we really reach environmental limit, it'll almost certainly be fresh water. And a lot of information that you can get on this very easily. It's not secret at all. There's two sources of water that humans can use, which is fresh water. You can desalinate salt water, but the energy costs are enormous, so it's not, unless you're an Arab and sitting on an oil well, you really can't do it in any reasonable way. So there's renewable water, which is rainwater. When it rains, that is renewable. There's a cycle of it goes up into the atmosphere and comes back down as rain. So you have renewable water coming eventually into rivers, and in one way or another you tap the rivers. And then there's mined water. What do? You mine it just like you mine coal. You dig down and you suck up the water. And the greatest productivity of a lot of the farm regions of the world comes from mined water. So the Midwest of the US, especially as you get further west in it, does not have enough rainfall, so they use mined water. And you probably have heard that the reason they can use mined water is that underlying our Midwest is what's called the Ogallala Aquifer. Ogallala is a name of one of the Indian groups that used to live there. The Ogallala Aquifer, and the farmers all over the West there just sink down a tube and suck up the water. Well, you have to think of, being a scientist, I always want to know how, why, where, all this kind of stuff. And since a kid, you read about, artesian wells and wells underwater, and then eventually ask yourself, how does water get into rock? And the reason is it drips in there. And the Ogallala Aquifer actually filled from the melt-off of the last ice age. Apparently the peak of the last ice age was about 18,000 years ago, and then it took about 8,000 years to melt until something like 10,000 years ago. Those are very approximate numbers. But for 8,000 years, ice was melting, the ground was soggy, and drip, drip, drip. Rock is never totally solid. There's always somewhere, some little crack, and the water slowly drips through the cracks and goes in. And any kind of, when the rocks get folded, there's caverns in there, and any kind of space, eventually water will find its way, drip in. If you've ever paid attention to the roof on your house, you know the water gets in, no matter what you do. So it's the filling of these aquifers is, I don't know, I can't remember when that ice age started, but it took 8,000 years to fill, but that depended on a glacier which was there for the previous 10,000 years. So we're talking about a resource that is one of the shorter term resources, and it's something like it fills in 20,000 years. Now we're sucking it up in decades, and it's very much going way down. And there were some slides, and the reason I was a little late, I could not find the slides this morning. I had them yesterday, and I don't know where they went, so I didn't put them on. But they show some interesting kinds of things. That when you're sitting on top of this aquifer, you've got the rock and the water is there. Water's incompressible, so it holds up the rock. You suck out the water, there's now a space there. And what happens? The rock starts crumbling and falling down. And what happens is the land actually falls. And the pictures that I could not find show first from Houston, Texas, a farm there, and it shows you a pump. It's just a concrete platform with a pump, and you know where the land was, and then the land is several feet beneath that. The land is just shrunken, has collapsed. Then the second picture I want to show is Galveston, Texas, not so far from Houston. Now the land has fallen, again, all due to irrigation, but they're near the sea, so the salt water has come in. And now what used to be good agricultural land is now flooded with Gulf of Mexico. Are you from that region? She's shaking her head, as maybe she knows. But the most impressive picture comes from the San Joaquin Valley of California. Now you have probably, that's where all our fruits and vegetables come from. That's the huge source of American food supply. And probably almost all of you today have already eaten something that was farmed in the San Joaquin Anybody from that part? No, nobody from there. We don't have enough farmers at Yale. Well, this is a picture of a pole that they put in to measure the drop of the land. And what you see is this very large pole and a man. The man is sort of down here. And what the pole is the top of the pole is where the land was in, I can't remember, like 1957 or something like that. And the land has dropped 30 feet in that time. And the man is now, 5.5-foot man or 6-foot man, is a small fraction of this pole. It's really a shocking kind of photo. And of course, the agricultural activity in the valleys of California has only increased since then. The amount of water pumped has increased, and the land keeps falling at a very noticeable rate. So it's a very graphic thing. So now, from when you suck out the water, it takes quite a while for the rock to sort of collapse and fall down, because it's got some structural strength to it. So if you can see that how much the land has fallen, you can just imagine how much the water table itself has fallen, many times more than the actual land has fallen. And in some places, you can measure this fairly readily. So in parts of Texas and Arizona, water tables have dropped hundreds of feet. Even in northwest of Chicago, there's been a 200 to 300 foot drop in the water table, just sucking it out. 3/4 of Texas's irrigated area water tables are falling. And this is true all over the world. I mean, the United States is very technological, so we do a lot of drilling. But the North China Plain, which is again where the wheat in China is grown, drops 40 inches every year. Tamil Nadu in India, southern India, another very productive part of the world, 100 inches a year. The water tables are falling. There's just a study that just came out in February, which measures the groundwater levels that are of the water coming out of the Himalayas. So the Himalayas, as you know, sit right in the center of Asia, and the Yellow River and the Yangtze River sort of feed China, and you have the Helmand River feeds Afghanistan, the Indus River feeds Pakistan, and the Ganges River feeds North China, and you've got the Ganges goes into Bangladesh, the Brahmaputra, the Meghna, all feed the Bangladesh area. Then you have the Mekong and the Salween and the Irrawaddy, which do Vietnam and Thailand and Cambodia and Burma. So all of these come out of the Himalaya mountains. And what's happening, the groundwater in these regions is going down 2 to 4 meters a year. So that's 6 to 12, 13 feet every year the water table goes down. Venice is sinking for similar reasons. It's much smaller, only 9 inches in the whole century. Bangkok is sinking 13 centimeters a year. Mexico City, now, I hope I have those slides here? No, forget it. Mexico City is sinking in a drastic way, and there's since it's so prominent, there's very good data from Mexico City. So Mexico City put in a subway. Have you ever? Wonderful subway. I had a young lady with me when I was in the subway, and aside from getting squeezed, you get groped in the Mexico City subway. But they laid it flat. But now with the ground, the sucking out the water, the ground is sinking, and it doesn't sink evenly. So now the subway is like this, and some of it that was underground is now above ground, because the ground is just sunken away from the subway. The sewers and the water supply have exactly the same problem. Water pipe in Mexico City, the city itself has sunk 30 feet from when the subway was originally put down. Water pipe that was laying flat on the ground in 1934 is now 26 feet over everyone's head. And some suburbs are sinking about 2 feet every year. And
How come all this stuff doesn't also go down to the ground, like the pole?
Why doesn't it sink with the ground?
Because it's uneven, and I don't really know the answer to that. It's because why doesn't everything sort of just sink evenly? It just doesn't happen. So a flat subway ends up like
The
this.
pole in California, why didn't it just sink with the ground? What is it attached to?
Yeah, I don't know how they arrange that pole. You'd think that everything would sink. Yes, I don't know. They may, I don't know. Just don't know the answer. In Mexico City, the water supply, as more water is pumped, of course, the rate of pumping is faster. The city sinks faster, and the pipes eventually get twisted and they rupture. So there's now 40,000 repaired ruptures that they repair each year, and many more that they're not even reported, and they don't get around to repairing them. And apparently 1/3 of the water in the system leaks out. And a lot of the city lies below the sewer lines now, so the sewage doesn't leave the city anymore, it collects in pools, and they have now had to construct vast pumping stations to pump it out, the sewage back out from these pools. They're building a whole new, much deeper sewage system. They're building 124 miles of 80-foot sewers. Okay, that's enough. I think you get the message here. We may have a few more minutes. So I put in your reading, and just something that you may think, well, why did he put that in, is how much is being paid for caviar and fish and things like that. And it's part of a longer piece that I'm not going to have time to talk about, but there's a lot of fish in the sea, but there's a lot of people that want to eat fish. So fishing is one of those industries that's really just cleaning out the sea of fish. When there were small boats, things were okay, the fish could regenerate, but now Korea and East Germany and Japan have these huge, huge ships that have miles, their nets are miles and miles long, and they just suck everything out of the sea. So the fish are disappearing. And you'd think that economically, that as the fish disappear, and even when they can't reproduce themselves, it would get uneconomical to catch the fish anymore. But in actual fact, what happens is that in the fishing, there's presumably good fish that people like to eat, and what happens is, as those get fished out, you go down to the next level of fish. And if you've been going to restaurants for a while, you'll see there's every couple of years there's some new fish on the menu that I've never heard of. Have you had that experience? And that's because the fish that you ate 2-3 years ago are now gone, because they've been fished out. So the quality of the fish goes down and down. But if people have money, they still want to buy the better quality fish. And it turns out they will pay almost anything for this better quality fish. And so what happens is that instead of the economics working for you, that as it gets more expensive to catch fish, you let off on the fish, the price of the fish goes up so that it's still worthwhile to catch those fish. And what happens then, that because of that economics, the pressure to catch these fish to extinction keeps up there. And some of the outrageous prices that I gave you, that's the point of that kind of stuff. Okay, so what you should realize is that environmental destruction is essentially, a lot of it is irreversible. Loss of species is irreversible. I mean, if you want to wait 100 million years, yes, species will differentiate, you'll get new species, but that's basically irreversible. So things like fishing out various species in the sea so that they don't recover is an irreversible kind of thing. Loss of habitat is generally irreversible. That I think I described to you northeast of Brazil, or all of Brazil, all of any jungle region, where the whole ecosystem is kept going by the mat of fungi that recycle the nutrients in the jungle. And when you cut down the trees, the sun beats down, kills the fungi, you no longer have this mat of fungi, so now something falls into it, it doesn't get decomposed, the nutrients don't go back into the trees, and the whole land dries out and becomes what they call laterite, which is hard soil, hard like rock soil, and it's not clear that ever can recover. Fish stocks, the cod stocks declined like 20, 30 years ago, and they really have not come back. Even though they've really cut down the fishing and banned it mostly, they're not coming back. There's apparently too small of a population for the reproduction system to work well. Because this is irreversible, because this is a very important point, because environmental damage is irreversible, as population increases, as the world economy increases, the pressure on the environment gets worse and worse. You can imagine a nice scenario where eventually population comes down and maybe some of the pressure is let off. But what you have to worry about is that peak, because the things that are going to disappear irreversibly, your species, your habitat, your so forth, depend not on the level now, but on the maximum demand. That once and if the maximum demand comes off, it's okay. So what we have to worry about is this peak issue of population and other demands on the environment. And it's this peak issue that becomes important. We've seen the great range of variability in the UN projections. We could reach a peak at a billion more people, or 2 billion, or 3, or 4, or 5, or 6, or 7, 8, or 12, or who knows how many more billions. And which of those curves happens is not going to be a random event. It depends on what humans do right now. And because of momentum, the people that are born now are going to have children, and they're a cumulative factor in the environment. So whatever the birth rate now is, whatever the population growth rate is now, if that eventually stops, there's still momentum for another 100 or 150 years. And I showed you the data from various countries showing that even after they reach replacement level fertility, their population grows for another 100 years or so forth. So again, what we do now determines the maximum environmental destruction that's going on. But I think one of the most important points is that environmental solutions are difficult. It is not an easy job to fix the environment. Like global warming, there's huge arguments whether we should try to prevent it or should we just try to adapt it. And I think half your courses in the forestry school are, no, it's better to let it happen and it's going to be cheaper to adapt to it. And the other half of the course is saying it's a horrible thing, we've got to try to prevent it. And mostly like using solar power, wind power, the costs, nuclear power even, the costs are so very high that with current technology, the alternatives are really not feasible. So what's happening is China is building a new coal plant every week. They're not, they would love to reduce their pollution. They've done whatever they can, but their population is still growing. They have a huge poor population. They need the energy. They have no choice now but to build power plants. And what do you tell the Chinese to do? No, your people should keep being poor, don't build the coal power plants. Well, we don't say that, and they're not going to do it anyway, because their people demand some decent standard of living, which requires energy. So the CO2 in the air goes crazy. So there are no easy fixes for the environment from that kind of side. It's a really very hard job. The only success that one can really claim in the last, say, 50 years for what you might call the environmental movement is on the population front. You've seen, I've shown you many, many times that around the third world, up till 1950, 1960, the birth rate was 6, 7, 8 children per woman. And now it's dropped to below half that. In fact, to about 2.8, so something like less than a half of that. Enormous progress in that area. I've shown you, again, in many different ways, that people want fewer children than every country, every developing country of the world, that you ask how many they want, you find out how many they have, that in every country, the number that they're having is above what they want. And massive effects, actually like Bolivia, which is not one of your most advanced countries, and universally around the world, 70–80% of the women want to not have children. 70% just totally don't want it, another 10%, well, not in the next 2 years. So the technology we have, condoms are not wonderful, birth control pills are not wonderful. It's not wonderful, but it's good enough to do the job. So population is the rare issue where a lot has been done and a lot can be done. We don't have to win the hearts and minds of the people. They're already telling us they want fewer children than they're having. We don't need new technology. It's dirt cheap compared to like getting rid of carbon in the atmosphere or reducing its dirt cheap. I mean, a cycle of pills on the world market is 80 cents. A diaphragm is $1.25. I mean, we're talking dirt cheap. And the medical knowledge to provide these things is almost at the barefoot doctor level, so you don't need very highly trained personnel. And as I've mentioned to you, labor and even educated labor in the developing countries is cheap. So, of all the possible things one can do to improve the environmental situation, it looks to me like encouraging the continued decline of fertility is the easiest thing. You don't have to spend a lot of money. Most of the people in the world will be, yeah, rah, rah, I want that. And we've seen from Ryerson's lecture here that with a very little bit, I mean, he puts on one soap opera, you know, which runs for 2-3 times a week for like a year, which is significant, but very small intervention and very cheap. And the number of people going to family planning clinic doubles and triples. I mean, just incredible amount of progress with a very small input. So this is a very, very doable thing. And we have a long way to go. The fertility, as I've said, has come down from 6, 7, 8 to 2.6 as a global average. But 2.6 is still a 30% increase every generation. So population growth, I just showed you, is about 1 billion people every 13 years now. And it's still very high. Bringing it down further is probably the only feasible, reasonable, realistic thing that one can do to massive, I mean, the environment is going to hell in such a massive rate. We need some massive change, and I don't think anything else comes close to what you can do with population. I challenge environmentalists all the time. I say, look, every 13 years there's another 1 billion people. Add up all the environmental all the conservation that environmentalists have ever done, all the restoration, add that up and compare that to a footprint of 1 billion people in 13 years. It's not in the same, you're just not in the same ballpark. And yet that message doesn't get through. There's a wonderful quote, and this is, maybe the cameras don't even want it, that Peter Beard, who's one of the most famous conservation writers in Africa, and he's very outspoken and does not use polite language all the time. This is a quote from him. I broke my ass to do these conscientious books. He did all kinds of books on the environment in Africa. But the public's not getting it at all. You show them photographs of 30,000 carcasses with the ivory tusks still in place. That's elephant, 30,000 ivory elephants. And the tusks are still in place. And they try to tell you that we should prosecute poachers, as if that was the issue. Doesn't anyone realize that people are hungry and using these animals for food? People still think it's wild Africa. Doesn't anyone realize that this is all about population pressure? And he uses the F word, what the F's going on out there in the conservation word. He capitalizes con as for con job. Nothing but lies, fundraising lies. And I think we are. I mean, he overstates things, and as you know, that's one of my pedagogical tools, is to engage somewhat in overstatement. You remember it, though. And so, you know, that the whole environmental movement has got its head in the sand about the one thing that could really probably make a big difference. So, just to conclude, that the Earth is in a big race. I've shown you population is increasing, environmental problems are increasing, but fertility is coming down. Depending on how these two countervailing forces work, in the future we will either come to a smooth landing, a soft landing, that fertility will come down fast enough that takes the pressure off the increasing environmental issues, and or it won't, or population won't come down fast enough. And then we're off into who knows what. So that's, I think, what to take away from this course, the tremendous race between the increase of population, 1 billion people every 13 years, the decline in fertility, declined since 1960 in about 40, 50 years, inclined to more than half. How is that race going to be won, and which side is going to win that race, and what can we do about it? Okay, have a good summer, have a good test.